Welcome to Study Loop.
35. So we have 35 grams of ice, which is at its melting point, which is 0 degrees Celsius, assuming it is at standard pressure. And it is dropped into liquid nitrogen. Liquid nitrogen has a boiling point of 77 Kelvin. And to convert this into degrees Celsius, we simply remove 273 from it, which gives us 109 minus 196 degrees Celsius. So the ice goes from 0 degrees Celsius to minus 196 degrees Celsius because it cools down. But at the same time, the heat is transferred into the liquid nitrogen. The ice gets colder and the liquid nitrogen gets hotter. So this heat that goes into the liquid nitrogen helps evaporate some liquid nitrogen. But the liquid nitrogen is already at its boiling point. So the only heat needed will be its latent heat of evaporation. We know that latent heat of evaporation of liquid nitrogen, latent heat of evaporation is 200 into 10 cube joule per kilogram. So the symbol for latent heat of evaporation is L, VAP. Now that we have this, we know that the amount of heat released from the ice is mc delta T, the mass of ice times the specific heat of ice times delta T. The final temperature is 196 degrees Celsius and the initial temperature is 0 degrees Celsius. So that's our delta T. Now this is the amount of heat lost from the ice. Plus, now the amount of heat gained by the liquid nitrogen will simply be the mass of liquid nitrogen that is evaporated times the latent heat of vaporization. Now this must be 0. This gives us the mass of nitrogen that has evaporated is equal to mass of ice times specific heat of ice times 196 divided by latent heat of vaporization. Now we can simply plug in the numbers. Mass of ice is 35 grams, which is 35 into 10 power minus 3 times C, the specific heat of ice is 2100 joule per kilogram degree Celsius. We know that delta T is 186 already. Now divided by 200 into 10 cube joule per kilograms. This gives us, when you plug it into a calculator, 7.2 into 10 power minus 2 kilograms, which is 72 grams of liquid nitrogen.